I keep hearing about MCP and how useful it is for AI apps. At this point, I'm almost afraid to ask, what is it and how does it work?
Well, Martin, let me show you.
Welcome to the show, Jack. What do you do here at Google?
Thanks for having me, Martin. Well, I'm a Python developer advocate here at Google Cloud, and my background is in open source client libraries, specifically on databases and making the connection experience smooth.
Excellent. So what is MCP and why is it useful?
Yeah, well, MCP stands for Model Context Protocol. It's an open protocol developed by Anthropic that standardizes how we provide context to large language models, or LLMs. There are three main components to MCP, but today we are going to focus on tools.
Okay, tools. That sounds a bit abstract to me. What are they?
Well, tools give an LLM or agent the ability to take action in the real world through discovering and calling external APIs, querying a database, or running custom code, you name it.
That makes sense. Who would use MCP?
MCP really is useful for a wide audience, but I see most users falling into one of two groups of people. If you provide an API or a service, you may want to use MCP to package your API into MCP tools so that clients and agents have an easier time using it. If you are a developer using AI-assisted IDEs or building AI agents, MCP makes it easier for agents to use an API or perform actions on your behalf. For example, an MCP server for Cloud Run. A developer can ask in plain English to deploy a Cloud Run service, instead of having to know all those pesky G-Cloud commands.
Those pesky G-Cloud commands. Yes, I feel you. And where would you deploy this MCP server?
Good question. You have lots of different options. You can run an MCP server locally. For example, if you want AI help when you are writing code in your editor. You can also have remote MCP servers if you want to share it with others. I think deploying MCP to Cloud Run on Google Cloud is a great option.
All right, let's get down to brass tacks. What might a real use case of MCP look like?
Yeah, let's say Alice is an API provider. Her company sells sprinkler systems for lawns. She partners with lawn care companies who install these sprinkler systems. To make life easier for them, she provides an MCP server with a tool that they can call to get a price quote. She has deployed the MCP server on Cloud Run, which is serverless, so that she doesn't have to worry about the infrastructure.
Got it.
David runs a lawn care company. He provides an AI chatbot that his customers can use to get lawn care tips, to schedule visits, or to place orders, and so on. If David points his AI agent to Alice's MCP server, the agent can now provide quotes for installing sprinkler systems.
Oh, Shadow, please get down. Okay. All right. Sorry about that, Jack. I see. So what would the end user experience be?
Yeah, let's say we have Eve, who is the end user. She might use David's AI chatbot to ask for general lawn care tips, like when is the best time to water her lawn. She might also ask how much it would cost to install a new sprinkler system. David's chatbot can actually answer this question thanks to Alice's MCP server and API.
That makes sense. Now, I'm a developer. What does the code for all this look like?
That's an important part. Let's start with Alice's MCP server. She has imported the FastMCP library and added this mcp.tool decorator to the calculate quote function. That annotation is all it takes to expose this method via the MCP protocol. So AI agents can now use it. The body of that function is the business logic for calculating the quote itself. The price quote depends on which country the customer is in, as well as the square meters they're on.
All right. That looked pretty simple. Now, how would David's agent call Alice's tool to calculate a quote?
Let's take a look at the actual code for David's agent. When you build an agent, you can provide an array of tools or functions that it can call. David's provides a single tool of type MCP toolset, which contains the address of Alice's MCP server.
Okay. And when I've given tools to agents before, I remember having to provide which input and output parameters each function takes and a description of what each function does. But David didn't have to do that here.
That's right, he didn't. He just pointed the agent to Alice's MCP server URL, and it figured out the rest.
And then David's agent called Alice's API?
Yep, it did. Alice is running her MCP server on Cloud Run, so if she clicks on the Cloud Run service logs in the console, here's what it looks like. Here is the actual call made by David's agent.
That makes sense. And where would David run his agent?
Another good question. The agent was built using Google's ADK, or Agent Development Kit, and it was also deployed to Cloud Run.
Wow, a lot of Cloud Run in this example, huh?
Yeah, Cloud Run is serverless, which makes it really easy to deploy agents, MCP servers, or APIs. Google handles the configuration and scaling so that you can release faster.
Very good. But I have some questions for you, Jack.
All right. Go ahead, Martin.
So the point of MCP is that agent developers, like David, don't have to tell the AI what the input and output parameters are?
That's one advantage of MCP. Another reason for MCP is that previously your tools had to be built for a specific framework like LangChain or Visual Studio Code. MCP is a common protocol that many clients can use. On the other side, developers who expose their APIs with MCP, that way Alice's API or the API for a calendar, email, or local file system all appear the same and make it easier for AI agents.
And you said before that we'd put the MCP server in the cloud to make it available for everyone, but Alice might want some authentication for MCP server, so only registered partners like David can use it, right?
Yes, luckily MCP has support for authentication. I will note that it is fairly new and still evolving. MCP supports OAuth, which is great for when users like you or me want to authenticate. You can also lean into Cloud Run's existing authentication infra to use with MCP like BearerAuth. This is a great choice when you are wanting service-to-service authentication.
I see. What does this MCP protocol actually look like?
Good question. Let's take a look. I have the MCP inspector pulled up on my computer. Here we can see that the tools is an array with a single entry called calculate quote. That tool takes two inputs, square meters and country code. Both are required.
That looks a little bit like an OpenAPI spec. What's the difference?
That's an important question. An OpenAPI spec is lower level. For example, it includes the HTTP status codes that an API can return. The MCP server skips those implementation details.
In the code you showed, Alice used Python and the FastMCP library. All is good. But what if Alice already has a well-tested API and doesn't want to change it? She just wants to expose her existing API to AI agents.
Totally. FastMCP actually has built-in support for this exact functionality. You can point it to your OpenAPI spec, and it will actually generate an MCP server. Another option is to write a small proxy, using FastMCP that forwards any calls to the underlying API.
Very good. Now, let's recap. What are the main takeaways here, Jack?
As I was first learning about MCP and writing my first MCP servers, here's what I learned along the way. 1, MCP is super useful as a common language for declaring tools for our AI agents. 2, if you want agents to use your API, expose it with MCP. And 3, it's super easy to run an MCP server on Cloud Run.
Great takeaways. Thanks for joining me today, Jack.
Thanks for having me, Martin.
And thank you, everyone, for watching. If you have any questions for Jack or me, ask in the comments. And do let me know what you thought of today's episode. I read every single comment. I can't wait to see what you build.